Okay, so for today we're going to look at the different quadrants of 2, 3, and 4 mostly, but sometimes we are going to still stick with some of the quadrants some of the values in quadrant 1. On the last one we looked at the trends, so we looked at what happened as to our sine values as we were going closer and closer to the 90 degree angle, and same thing with our cosine. And we found, so this is what we looked at on the last one, was that this first coordinate point that we have is 1, 0, which tells us again our cosine and our sine value. And this coordinate point, so this is at 0 degrees, this is at 90 degrees. This coordinate up at the top is at 0, 1. So as we are going from 0 degrees, as our theta, our angle that's formed in our first quadrant of our reference triangles, is going from 0 degrees to this 90 degree angle, our sine of theta approaches 1, meaning it goes from 0 to 1, so it's going to increase. And our cosine value is going from 1 to 0, so it's decreasing. And we said the same thing about tangent. We said tangent was something increasing over something decreasing, so that was going to increase in quadrant 1. Okay, so let's put in all the other stuff. This is 180 degrees, this is negative 1, 0, and this is 270 degrees, which is at 0, negative 1. So I want you to actually pause the video for a second, and I want you to see if you can come up with quadrant 2, labeling it as increasing or decreasing, quadrant 3, labeling them, seeing what they're approaching and labeling it as increasing or decreasing, and then quadrant 4. So hopefully you did get a chance to do that. So if we're looking at sine of theta and we are going from this value of 90 degrees to 180 degrees, our sine is going from 1 to 0. So we're approaching 0, and since we're going from 1 to 0, we're going to decrease in quadrant 2. Now, I said in our last video about how you can imagine these triangles that are being formed. It makes sense that as we're forming triangles and getting an angle that's bigger here in quadrant 2, and bigger meaning because it's already coming from this terminal side, this x-axis, all the way over. These angles are between 90 and 80, so they're getting bigger, but the reference angle is actually getting smaller as I'm drawing my triangles. Remember, that reference angle is between our terminal side and the x-axis, so that's the reference angle that we're dealing with. And as I'm drawing my triangles, my opposite side, my y value, my sine value, then is decreasing, getting smaller and smaller. And then my cosine going from 0 to negative 1, although the absolute value is getting bigger, I'm still going in the negative direction, so I'm going from 0 to negative 1, which means it's decreasing too. In quadrant 3, my sine value is going from 0 to negative 1. So again, the absolute value of it's getting bigger as I'm drawing my reference angles in here. My opposite side is getting bigger, but it's getting bigger in the negative direction. So I'm going to negative 1 and it's decreasing here. Getting bigger in the negative direction. So it's kind of weird to think about it being decreasing even though it's getting larger. My opposite side as I'm drawing my reference triangle is lengthening, but it's lengthening in the negative side. And cosine is going from negative 1 to 0. So that thing is actually increasing. And same kind of idea, it's like a double negative. My cosine value is actually getting smaller, but it's getting smaller in the negative direction, which means it's getting bigger in the positive direction is another way to think about that. And then as my theta is going to 360, from 270 to 360 degrees, which is right back to where we started with our coterminal angle with 0 degrees, our sine value is going from negative 1 to 0. So that's increasing. And our cosine value is going from 0 to 1, which is also then increasing. So we're moving up, which means that our sine value is increasing because sine is our y coordinate, which is up and down. So we're getting closer, we're gaining in our y values, but we're also moving to the right, which means we're gaining in our x values too. As kind of a general rule of thumb, as we're looking for like our explanation pieces for our next test, mostly I'm just going to ask you to explain quadrant 1. So explaining how these are increasing or decreasing, explaining how tangent might be increasing or decreasing, explaining how cosecant or secant might be increasing or decreasing. You pretty much have to have these explanations of how these things are behaving in quadrant 1 down. The most of the other tests, though, that we have coming up for Chapter 2 is mostly dealing with this stuff, where we're actually coming up with the reference angles and reference triangles and the exact trig values for each of these. Remember that reference angle is an angle that has the as an angle that's formed between the terminal side and my x-axis. So in, say, if I have some reference triangle in quadrant 2, the angle that would form that would be this one. This would be theta. So it would be between 90 and 180 degrees, but my reference angle always has to be part of a triangle. So my reference angle is always going to be between 0 and 90 degrees. It's always going to be some acute angle. So my reference angle would actually be this one. So to find our reference angle, say for quadrant 2, we would have to take 180 and subtract then this like brown angle that I drew, and that would give me my reference angle. So that's what we're going to do for example 1. This 120 degrees is between 90 and 180. So if I draw in my reference triangle at 120 degrees, we'll just say it's about here, I don't really know. So this whole thing here is 120. I'm looking though for my reference angle. So reference angle. That would be between this axis here, my x-axis, and my terminal side. So I know this whole thing here is 180. And I know this part's 120, so this leftover piece is 60. So my reference angle here is actually a 60-degree angle. Now that I know my reference angle, then I can come up with my cosine value and really all of my other 6 trigonometric values. I know again that my hypotenuse on the unit circle is always 1. This is my 30-degree angle because this is my 60. So across from my 30-degree angle is always going to be that 1/2. In this case, since I'm in quadrant 2, don't forget your negatives, they will get you. And then this side would be my √3/2, always my opposite side, or my across my 30-degree angle, my smaller side times √3. So my cosine of 120 would be my x value, which would be -1/2. As we're going through this, make sure that you are indicating what angle you're referring to. So no longer are we going to say this, because that doesn't make sense. We have to, since we're evaluating at a specific angle, we have to make sure that we put the angle in there. This would actually be solving for the angle, like the actual angle that would give that. So we're going to do stuff like that later, but notationally, we should make sure that we're actually evaluating at that specific angle. Okay, let's try another one, and then I'll have you try some yourself. So this is cosecant of 315 degrees. That tells us that we are in quadrant 4, because that's between 270 and 360. So cosecant right now, quadrant 4, that's going to be negative. So I'm going to remind myself later that whatever answer I get, I have to make sure it's negative, because cosecant goes along with sine. Sine is negative in quadrant 4. So here's my triangle. Again, this entire angle, I'll draw it out here. This whole thing here is 315 degrees. So what I'm looking for is this reference angle. So to go all the way around, it's 360, but I only am going 315 degrees away around. So if I take that and subtract those two values, what I should get is a 45-degree angle. Now that's our reference angle that we're looking for, 45. So our reference angle, 45 degrees. Now you don't have to write this ever, as just for me right now as I'm taking notes to write it out, but you don't have to do that. 45-degree reference angle, my hypotenuse is 1. Again, I could solve for, but this is kind of what we did yesterday. To solve for those specific angles, what we found is that they're always √2/2. And again, don't forget, we are in quadrant 4, which means that this value here is going to be negative. So if I am looking for cosecant, that means I'm dealing with my sine value. 315, excuse me. Cosecant of 315 is 1 over my sine value of 315, the reciprocal of that, which is really that thing turned around. So I'll get -2/√2, and I'll rationalize Negative 2 root 2 over root 2 times root 2 is 2. Those will cancel out, and I'll be left with negative root 2. We saw that yesterday too, that we'll get root 2 over 2 and then root 2 singular. Okay, again, I kind of want you to stop the video, if you would, pause it and try these two, because we're getting kind of the hang of how to draw these and the reference angle that's located. Don't forget what quadrant you're in, so make sure that you label out the quadrants that we're looking for, and then kind of watch through or double check your answers. So for this one, what you should have found as you're working that out was that we, as an angle of 240, we're between 180 and 270, so we're looking at, oops, so we're going to write 240 down, quadrant 3. Tangent's positive in quadrant 3. Sine and cosine are negative, but tangent itself is positive. So when I draw my reference triangle here in quadrant 3, I know that this whole angle here, all the way around that section here, is 240. So to come up with that, I could do 270 minus 240, but I'd end up with this piece. So instead, what I would do is I would actually do, since this includes the angle, I would do 240 minus 180. So like take the whole thing and then subtract this piece, and then you end up with your reference angle there. And that would be a 60-degree reference angle. So there's my reference angle, which means since it's 60 degrees, this is going to be the root 3 over 2 side. This is my 30-degree angle, so it's across from my shorter side of the 1/2. Don't forget that it's negative, and then obviously my hypotenuse here is 1. So my tangent of 240 is going to be my sine of 240, which is negative root 3 over 2, over my cosine of 240, which is negative 1 over 2. If I multiply by the reciprocal, my 2's will cancel out. I'll have negative root 3 over negative 1, which will be positive root 3, which is what I'm looking for as a positive value in quadrant 3 for my tangent. Here we go. Go back through and box those. Okay, same idea for secant. This one's a little bit harder to find the quadrant. In order to get there, I need to make sure I come up with a coterminal angle. So I'm going to take 495, subtract 360. That'll tell me where I am, which is at 135 degrees. So that's a coterminal angle, which that means that I'm in quadrant 2. My secant in quadrant 2 goes along with cosine. My cosine in quadrant 2 is going to be negative. So I'm going to keep that in the back of my mind as I'm coming up with my coterminal angles and my reference triangles and all that other stuff. So I'm in quadrant 2. This angle again is 135 degrees. So I'm looking for this angle. So to find quadrant 2, I'm going to take 180 and I'm going to subtract 135. And that'll give me a 45-degree reference angle. Since we're dealing with the 45-degree reference angle, my triangle sides are going to be root 2 over 2 and root 2 over 2. But again, I'm in quadrant 2, so don't forget that my x value here is negative. My secant is 1 over my cosine, so my secant of 495 degrees is going to be 1 over cosine of 495, which is the same thing as 135 here because they're coterminal, which means I'm going to take the reciprocal of that. So negative 2 over root 2. We've done this problem already up above, so when we rationalize, we should get our same answer of negative 2 root 2 over 2, and then that again will simplify down to just negative root 2. Again, a lot of your tests for chapter 2 has to deal with drawing these reference triangles, drawing them right, figuring out the reference angle, and figuring out where you are as far as negative and positive is concerned. And if you can get a good grip on this lesson today, then your life will be a lot easier in trig, because we do this so many times, figuring out what our reference angle is, what then our sine is, what our sine value or cosine value or tangent is, but then also what our sine of those trig functions are. Last one, cosine of 180 degrees. That is a quadrantal angle. We've done that on the last test. Our cosine value is the x value at that point. The x value at that point is -1. So that one's something that you don't have to find like a reference angle for or anything, because it's already something that's a quadrantal thing. It's on the axis, so we don't have to deal with any triangles that are formed. So on the back side, it's just more of that. So we're going to do it one more time, but we're going to do that in a evaluation standpoint, so something that we're like actually computing. For each of these, we're going to draw a reference triangle for it. So let's deal with my 60-degree angle. My 60-degree angle is in quadrant 1. That tells me that my cosine, that's going to be something that's positive. So just keep that in mind. If I'm dealing with a 60-degree angle, that already tells me my reference angle, so that's no big deal. My 30-degree angle is up here, so that would be 1/2. This would be √3/2. Since I'm dealing with cosine, I'm dealing with my x value, so this part here is going to be 1/2 and positive at that. Okay, we're going to come up, and again, I'm going a little bit faster here, so hopefully you're kind of getting the hang of how this works. My 135-degree angle is going to be in quadrant 2. My sine value is going to be positive there. So here's my reference triangle. I need to come up with my reference angle. So in quadrant 2, I'm going to do 180 minus 135, and that gives me a 45-degree reference angle. So that's here in the corner. And since that's a 45-degree angle, I've got isosceles triangles, which means I'm dealing with √2/2 and √2/2. And again, don't forget your negatives. In this case, it doesn't actually matter because we're just dealing with our sine value, which is positive. But if they ask me my cosine value here, I'd have to make sure that I include that negative, because my cosine, my x value, is negative in quadrant 2. So here's my sine value at 135 degrees is √2/2. Now they're saying sine squared, so I'm going to take that quantity that I have and then square it. And 330 degrees is the last one. So 330 degrees, 270, and 360. So I'm going to be in quadrant 4. So this whole thing here is 330. So I'm trying to figure out how much extra I would have to go there. So I can take 360 and subtract 330, and that would give me my reference angle of 30 degrees. 30. Again, don't forget that we are in quadrant 4, which means my cosine here is positive, my sine value here is negative, so my tangent overall is going to be negative. So crossing my 30 degree is 1/2, and it's negative since I'm in quadrant 4. This part here is going to be positive, √3/2, crossing my 60-degree angle. My tangent then of 330, I'm going to simplify down here, is my sine, which is -1/2, over my cosine value, which is √3/2. Now for this one, again, our hypotenuses cancel, and I'm left with -1/√3. For this one specifically, I'm going to leave it like that because I'm going to plug it back into this thing and square it. But you could rationalize it, and you should get -√3/3, and that's also a possibility. But I'm only going to plug it back in here and square it anyway, so I might as well just leave it like that. So if I plug in my -1/√3 and then square it, then I have something that I can now evaluate. So I'll have 1/2 plus √2 squared is going to be 2. 2 squared is going to be 4. And then minus, I'll have -1 squared is going to be 1. And then √3 squared is going to be 3. So I'll have 1/2 plus, this will reduce down to 1/2 as well, minus 1/3. So this is 1 minus 1/3, which will give me 2/3 as my final solution for that evaluation. This one also didn't quite matter about our signs that we looked at, because both these things, this one was positive, but both of these ones were something that was a quantity squared. So when we squared it, we still had a positive value. This, although, by the way, doesn't get, since we're subtracting this quantity squared, this will still be a positive quantity, and it'll still be that we're subtracting it. So just make sure that you don't like change that to plus or anything. And last one that's kind of like that is down below. We're trying to decide if this identity would be true. Like, is it possible? A lot of times I like distribute things throughout, like 4 times quantity x plus 4. I could distribute that 4 throughout and get 4x plus 16. This question's saying, can we distribute that sign? And so you might be thinking right now, like, oh, maybe I can just find the sign of 30 and the sign of 60 and add them up, and that would be the same thing as the sign of 30 plus 60, or the sign of, A plus B, as these are 2 different reference angles. So to decide if that's true or not, we're going to plug in some numbers and decide if we can get the same thing. So these are my 2 angles that I'm dealing with, 30 and 60. So I'm going to draw 2 reference triangles over here. This is going to be my 30-degree reference triangle and my 60-degree reference triangle. So both of them are going to be in quadrant 1. And your triangles don't have to be that accurate or anything. I'm just using them as a guide. Quadrant 1 means my sine and my cosine are all going to be positive, so I don't have to worry. Across from my 30-degree angle is going to be a 1/2, and then root 3 over 2. And then flipped for my 60-degree reference triangle, across from my 60 degrees at root 3 over 2, just like this one was. This is my 30 degrees, so it's going to be 1/2. So on this side, my sine of 30 degrees, my y value here is 1/2. For this one, my sine of 60 degrees is root 3 over 2. So we're trying to decide, is that the same thing as sine of 30 plus 60, which would be the sine of 90? Well, 90 degrees is a quadrantal angle. That's up here. So that's at the point of 0, 1 on my unit circle, where my sine value is my y value, so that'd be 1. So is 1 equal to this? The answer is definitely not. So it's not possible to distribute. Don't make that mistake. This is not a thing that you can do. You can definitely not distribute trig values. Just like I couldn't do this. This is the same as if I took this quantity. This is not equal to the square root of x and plus the square root of 2. Those are not the same thing. Or x plus 2 is not equal to x squared plus 2 squared. I can't distribute a square. I can't distribute a square root because also those are functions. Sine is a function, so I can't distribute a function throughout. I can distribute a number, but I can't distribute a function. So just keep that as the same, hopefully that makes a little bit of connection. This last part is a little bit different. We are looking for, again, we're kind of coming up with our reference angles and trying to figure out our quadrants and what our sine value would be of that. But we're going to approach these ones a little bit different. So it tells us that we have an angle, theta, that is in the interval from 0 to 180 degrees, or 90 to 180. So that tells us right now that we're in quadrant 2. And we're going to do some manipulation to that to figure out if we change it, if we add and subtract some values, so we divide by 2, what will actually happen. So before, it is in quadrant 2, but I'm going to write it a little bit different because I think it makes sense to write it as an inequality. So I'm going to write theta between 90 and 180, and that allows me to do some manipulations to figure out this piece. So if I want to add 90 to my interval, so this is the one we're starting with. If I want to add 90 to theta, I'm going to add 90 to each of my quadrants. Really what that's doing, again, is just I'm between this angle and I'm shifting it 90 degrees, rotating it. And I'll get between 180 this time and 270. So we're looking for, again, this middle part doesn't really matter. We want it to match this. What quadrant is now theta plus 90? Well, it's between 180 and 270, which means that we are in quadrant 3. And again, that should kind of make sense. If we add 90 to that, basically what that does is rotate it 90 degrees. Okay, well, what about theta over 2? So I'm going to start again with my original, and I want to cut it in half this time. So I want theta over 2 to be in the middle. So I have to cut everything in half. So now I'm between 45, theta over 2, and 90. So what quadrant is between 45 and 90? Or what quadrant is that? That's going to be in quadrant 1. What's the sine of cosine of theta over 2? Well, theta over 2, we already know from above, that's going to be in quadrant 1. So what's the sine of cosine in quadrant 1? That is going to be positive. What's the sine of theta plus 90? Well, we know that theta plus 90 is in quadrant 3. We already did that in part A. So what's the sine of sine in quadrant 3? That's going to be negative. And the last one's a little bit hard. We are looking for the sine of tangent of negative theta. So here's my original. And now I want negative theta. When I do a negative or I multiply everything by a negative, I have to make sure that I'm switching my inequalities around because otherwise it doesn't make sense. So now you can do it two different ways. This is one way to do it, is you can like look at between your negative values. If I'm going between negative 90, which is going this way around my unit circle, this would be my negative 90 and then my negative 180. So that tells me I'm here in quadrant 3. Or another way is to find a coterminal with each of these. So I could add 360 degrees to each of those, and I would get 270 theta and then 180, which still, so if I add 360, I'm still going to keep it as like, negative theta, just because negative theta plus 360 is going to be the same thing as negative theta because they're coterminal. But you'll get between 180 and 270, which still puts you in this quadrant between 180 and 270 degrees. So either way, you're going to end up here in quadrant 3. And if you're looking for the sine of tangent in quadrant 3, the sine of tangent in quadrant 3 is going to be positive. So that's part 2, is kind of manipulating and figuring out what sine our different trig functions are in these different angles as we manipulate like a given interval. We might double it, we might divide it in half, we might shift it 90 degrees, we might shift it 180 degrees, we might subtract 180 degrees, subtract 90, add 270, add a coterminal. All those things might happen to find a manipulation for it. But the big idea for today mostly is actually like kind of this section where we're leaning towards kind of drawing these 3 different reference triangles and coming up with the values that are associated with it at those particular values, not forgetting the signs, and then coming up with drawing your reference triangles and then finding like our corresponding trig values with it.